All right, I hope you all had a fantastic break. And so what we're going to do today is just make sure that you know what you need to do for Create Task Row 5. And by the end of today, I'd like you to finish this in class today to turn in Day 5 Reflection Journal on Schoology. So this is the wrong due date. It's not January 5th and 6th. It's the next class period that it's due, and the due date has been fixed in Schoology. All right, so today you are going to take a look at the features of successful algorithms. You're going to continue coding and continue journaling. So you're going to make sure by the end of class that you know what you've completed, what you have left to do, and decide whether or not you're on track to sort of complete the course and be ready. You have to be done by January 25th or 26th. Okay. All right. So we've looked at rows 1, 2, 3, 4, and 6. Today we are going to look at row 5. Okay, so this is row 5 or response 3C. So this is a good day to make sure that the procedure you develop for row 4 has sequencing. It's automatically going to have that selection. That is going to be your if or your if-else statement, and iteration, some sort of repeat block. Okay. All right. So your written response has to include a student developed algorithm. This is going to be in that pink block, or you could have an algorithm that's somewhere else in your program. But that algorithm has to have sequencing, selection, and iteration. Now, you also have to explain in detail how the algorithm works so that someone else could recreate it, okay? So you have to be very specific here. So you will not earn the point if the response only describes the algorithm without explaining how it does it, okay? So you want to explain how the algorithm works and so that someone else could recreate it. Okay, make sure that the algorithm is in the program code. So once again, you have your procedure, you've taken screenshots of that, you've used that in your video. This has to match that. So you're describing basically your procedure here. Okay, the code segment consisting of the selected algorithm is not included in the written response. So if these are different, so if you take a Snagit but explain something else, it's not going to count. Okay, so keep in mind that they have to be the same. Okay, you have to make sure that the algorithm is identified. So make sure that you're stating the name of your procedure here. Okay, and then also it won't count if the use of selection or iteration is trivial and doesn't affect the program. So if it's just having somebody jump up and down, then that is not necessarily going to be like crucial to your program. So you want to make sure that what your program here is crucial to your program. All right, so here's your requirements for the code segments. So number 1, it can utilize existing language functionality or library calls. You don't need to worry about that too much. You have to have sequencing, selection, and iteration. Okay, and an algorithm containing sequencing, selection, and iteration that's not contained in a procedure can earn this point. So that's fine. So hopefully it's in your procedure so you don't have to worry about it. But if you've created it outside your procedure, that's okay too. Okay. Use the first code segment as well as any included code for the procedure called within the first code segment to determine whether the point is earned. Okay. So whatever is the first code segment that you took a picture of, that's what they're going to use, okay? If this code segment calls other student-developed procedures, the procedures called from within the main procedure can be considered when evaluating whether the elements of sequencing, selection, or iteration are present as long as the code for the procedure is included. So if you have a big procedure and then you have many procedures within that big procedure, as long as you show the code for that other procedure with sequencing, selection, and iteration, then you're good to go. Okay, so number 1, so you must explain in detail how the algorithm works so that someone else could recreate it. That is really, really important. So make sure that you are being very detail oriented here. You will not get the point if the use of selection or iteration does not affect the outcome of the program. So make sure that it is crucial to your program, the selection and the iteration. Now, this is just an example from our wedding registry example describes in general what the identified procedure does and how it contributes to the overall functionality. Okay, notice we name it, the procedure remove. We're naming the procedure, checks whether or not the input item is anywhere in the registry list. So it's telling what that procedure does, okay, and then it's saying if it is, we'll remove it from the list. So it is being very specific here as to what the procedure is doing. Now, the next one says, explain in detailed steps how the algorithm implemented in the identified procedure works. It must be detailed enough for someone to recreate it. Now, it doesn't necessarily have to be detailed that they could recreate it in Scratch. It's so that they could understand what the program does so they could recreate it in any other program. All right, so what this says is the procedure removes uses the parameter registry item to check if an item is anywhere on the list. Okay, so notice that works, that shows how it works, okay? And that is specific so somebody else could figure out how to do that on their program. So what does it do? It begins by setting a counter equal to the length of the registry list so that it can incrementally check each item, changing the counter by -1 at the end of the iteration. Okay, by -1, remember that means it's removing it and then going back up and checking to see if what the next item in the list is actually on that registry list. Now notice it's not using the scratch commands here. This is a general explanation so that someone could say, okay, I need to find some counter. I'm going to set it equal to the length of my list. And then however my program code is going to be completed so that I can check incrementally going down. Once again, it has to be so that anyone could recreate it. It doesn't have to be Scratch. So you don't need to be specific to Scratch here. And notice if the parameter registry item is on the registry list, then the item is removed from the list. Okay, so if you want to practice this, you can. You complete the It is a Good Algorithm worksheet. So what this is basically, this is you taking a look at this and you want to read this and say, hey, like, is this a good algorithm? Does this make sense? Take a look at this algorithm. Would this make sense? Okay. Is this a good algorithm? Would this make sense? And then what you can do is you can check your answers with the key, or you can just take a minute and look at the key and say, hey, what is this? Does this have all the criteria that's met for my algorithm, or is something missing? Okay, so you can use that. If you have any questions, you can let me know. So you need to spend the rest of your class coding, and then just make sure that you complete the daily journal for the last 10 minutes of class. So make sure you submit that. I will be grading this even though I'm gone. So I will be grading it by next class period, okay? And my check-in is, what code have you completed? So we want you to think about that. What code do you have left to complete? Do you have enough time? We've spent 6 of the 7 suggested hours coding so far. Next class, you're going to be working on finishing the coding and completing your video and your PDF, which I will explain what you need to do. All right, so if you're done coding, what you can do is you can start your write-up. If you click on this right here, you would be looking at pages 6 through 9. So if you scroll down, here's your write-up. So here's the questions that here's the questions that you're going to have to answer. So you could start working on that on a single Google Doc. If you have any questions, please let me know.